Next theorem is Lagrange's mean value theorem, that is LMVT. Question is what? Set and prove LMVT, Lagrange's mean value theorem. Suppose that the function f is number 1 continuous on closed interval AB, number 2 differentiable on open interval AB, then there exists at least one point C belongs to open interval AB such that f dash C is equal to f of B minus f of A divided by B minus A. So this is the statement of the Lagrange's mean value theorem. There are two conditions, that the function is continuous on closed interval AB and the function is differentiable on interval AB. In the Rolle's theorem, there are three conditions, that the function is continuous on closed interval AB, differentiable on open interval AB, and the third condition is what? F of A is equal to f of B. So in the Lagrange's mean value theorem, there are only two conditions, that the function is continuous on closed interval AB, and number 2 differentiable on open interval AB. Then there exists at least one point C belongs to open interval AB such that f dash C is equal to f of B minus f of A divided by B minus A. So we define the proof of the theorem. Let phi be a function defined on closed interval AB such that phi x is equal to fx minus ax, where A is constant chosen such that phi A is equal to phi B. So value of A is such that phi of A is equal to phi of B. So what is phi of A is equal to phi of B gives? So phi of A is this f of B minus A into A, because phi x, substitute x as A, and phi B is this f of B minus capital AB, and so phi A is equal to phi B means f of A minus A into A is equal to f of B minus A into B gives this. So shift this minus AB to LHS, we have plus AB minus AA is equal to f of B, shift this f of A to RHS, so f of B minus f of A. So phi of A is equal to phi of B gives capital AB minus capital A into small a is equal to f of B minus f of A. So take A as common, so we have A, value of A as f of B minus f of A divided by B minus A. Suppose this is equation number 2. Now phi satisfies all the condition of Rolle's theorem. That is, phi is what? Phi is the subtraction of fx minus ax. Ax is the polynomial function. Polynomial function is always continuous and always differentiable everywhere. And therefore, phi, the function phi satisfies all the condition of Rolle's theorem. That is, phi is the subtraction of fx. F is the function differentiable on open closed interval AB, differentiable on open interval AB. This ax is the polynomial function, is continuous everywhere, differentiable everywhere, and therefore the subtraction of two functions, this fx minus ax, is what? Is differentiable on closed interval AB, is differentiable on open interval AB, is continuous on closed interval AB, that this function phi x, is continuous on closed interval AB, is differentiable on open interval AB, and phi A is equal to phi B. And phi A is equal to phi B, and therefore phi satisfies all the condition of Rolle's theorem. And therefore, by Rolle's theorem, there exists at least one point C belongs to open interval AB such that phi dash C is equal to 0. What do we have? Phi dash C is equal to 0. So phi satisfies all the condition of Rolle's theorem, and therefore by Rolle's theorem what we have? There exists at least one point C belongs to open interval AB such that phi dash C is equal to 0. No, don't write f dash C is equal to 0. The statement of Rolle's theorem is what? The function f is continuous on closed interval AB, differentiable on open interval AB, and third is what? F of A is equal to f of B. And therefore, there exists at least one point C belongs to open interval AB such that the derivative of that function f is continuous. So f dash C is equal to 0. We have the point between A and B. So here the phi function satisfies all the condition of Rolle's theorem. That is, phi is continuous on closed interval AB, phi is differentiable on open interval AB, and phi is what? For phi A is equal to phi B. That is, the value at the first point A and value at the last point B are equal. and therefore phi satisfies all the condition of Rolle's theorem, and therefore by Rolle's theorem there exists at least one point C belongs to open interval AB such that phi dash C is equal to 0. That is the derivative of that function phi. Its derivative at that point is 0. Phi dash C is equal to 0. And what is phi dash x? Phi x is this. Phi x is fx minus capital X. So phi dash x is what? F dash x minus capital A, because the derivative of x is 1 and the derivative of fx is f dash x. And so phi dash C is equal to f dash C minus capital A. And phi dash C is equal to 0 gives f dash C minus A is equal to 0, because phi dash C is f dash C minus A. And therefore f dash C is equal to A. And what is capital A? Capital A is this, f of B minus f of A divided by B minus A. So we have f dash C is equal to f of B minus f of A divided by B minus A. And this is the statement of the, and this is the proof of the theorem, that we have to show f dash C is equal to f of B minus f of A divided by B minus A. Then next is the Cauchy's mean value theorem. So question is state and prove Cauchy's mean value theorem. So the statement is what? Suppose that the function f and g, there are two functions now, are continuous on closed interval AB. Number 2, differentiable on interval AB. Both the functions f and g are differentiable on open interval AB. And the third condition is g dash x is not equal to 0 for all x belongs to closed interval AB. Okay, g dash x is not equal to 0. And then there exists at least one point C belongs to open interval AB such that f dash C divided by g dash C is equal to f of B minus f of A divided by g of B minus g of A. Okay, so we have to show this, f dash C divided by g dash C is equal to f of B minus f of A divided by g of B minus g of A. So there are two functions now. So this is the statement of Cauchy's mean value theorem, CMVT. So the proof of the theorem, suppose let f phi be the function defined on closed interval AB by this notation, by this definition. Phi x is equal to fx minus capital A gx. This is the now equation number 1. So in the previous Lagrange's mean value theorem, the function phi x is what? Fx minus A into x. And here is the function is what? Phi x is fx minus A. In the place of x, there is here is gx. Okay. So at phi x is fx minus A gx, where A is constant chosen such that phi A is equal to phi B. And the phi A is equal to phi B gives. So what is phi A? Phi A is f of A minus A into Ga. That is, what is the value of phi A? That is substitute A x as A. So fa minus A capital A into Ga. This is the value of phi. And phi B is what? Phi B, that is substitute x as B. So f of B minus A into G of B. Okay. And therefore, the shift this term A minus A GB to LHS. So A into capital A into GB minus AA, and shift this f of A term to RHS. So f of B minus f of A. Then take A as common. We have GB minus GA in bracket, and then shift this GA minus GB on RHS. So we have capital A is equal to f of B minus f of A divided by G of B minus G of A, equation number 2. Now phi satisfies all the condition of Rolle's theorem, because what is phi x, or phi is the subtraction of fx minus A into gx, and both these fx and gx are the functions continuous on closed interval AB, differentiable on open interval AB. This is given in the theorem, and therefore their subtraction is also continuous. That is, their subtraction means what? Phi x is continuous on closed interval AB, is differentiable on open interval AB, and phi A is equal to phi B, means phi satisfies all the conditions of Rolle's theorem. That is the 3 conditions of Rolle's theorem, that the function is continuous, function is differentiable, and phi A is equal to phi B, and therefore by Rolle's theorem there exists at least one point C belongs to open interval AB such that phi dash C is equal to 0. Don't write f dash C is equal to 0, because phi satisfies the condition of Rolle's theorem. So write phi dash C is equal to 0. But what is phi dash x? Phi x is this. Phi x is what? Fx minus A gx. And so phi dash x is what? F dash x minus capital A g dash x. This is the phi dash x. And so phi dash c is what? F dash c minus capital A g dash c. And phi dash c is equal to 0. This phi dash c is equal to 0 implies f dash c minus a into g dash c is equal to 0, means f dash c is equal to a g dash c, and then shift g dash c to LHS. So f dash c divided by g dash c is capital A, and value of capital A is what? This f of b minus f of a divided by g of b minus g of a, and this is what? This is we have to prove that f dash c divided by g dash c is equal to f of b minus f of a divided by g of b minus g of a. So this is the proof of Cauchy's mean value theorem. So remember the proof of Lagrange's mean value theorem and Cauchy's mean value theorem by comparison method. That is, there is a minor change in the proof and statement of the Cauchy's mean value theorem and Lagrange's mean value theorem. Now we give a geometrical interpretation or meaning of Lagrange's mean value theorem. So draw this figure, x-axis, y-axis. Then this is the curve y is equal to fx. This is the curve y is equal to fx, and this point is a, f of a. So this is a, and this is b point. Okay, that is b f of b. So if we find f of a and f of b, observe f of a and f of b. These are not necessarily equal in Lagrange's mean value theorem. If you observe the geometrical meaning of Rolle's theorem, then if you observe this figure, then this f of a and f of b, this f of a and f of b are same, because in the condition of Rolle's theorem, f of a is equal to f of b. But in the Lagrange's mean value theorem and Cauchy's mean value theorem, f of a and f of b are not necessarily equal. So show this f of a and f of b at different level. So this is the point, starting point of this, suppose this curve, and this is the ending point. So this is the point a f of a. So a, x-axis a distance, and then y-axis is what? F of a. And this point is what? B f of b. This point is b f of b. Because if you draw perpendicular on x-axis, then it cuts x-axis at the point b and y-axis at the point f of b, suppose. So this point is what? B f of b. Okay. And then join this line. Join the a point, these 2 points a f of a and b f of b by the line, by the straight line. Okay, and now draw the perpendicular. These C1 and C2 there are 2 points now here, such that draw the perpendicular at the point C1, which is parallel to this line a f of a, b f of b, line passing through these 2 points, and draw the another perpendicular at this point C2, such that it is perpendicular. It is parallel to this line. It is, these 2 tangents are parallel to this line. So what is the geometrical meaning? Geometrically, the Rolle's theorem states that, geometrically write the statement that geometrically the Rolle's theorem states that, like this, like the Rolle's theorem, write geometrically Rolle's theorem like that, right? Geometrically, Lagrange's mean value theorem states that the function f is, like this statement. Geometrically, the Lagrange's geometrically, the Cauchy's mean value theorem states that geometrically, the Lagrange's mean value theorem states that the function f is, number 1, continuous on closed interval AB, number 2, differentiable on open interval AB. Then there exists at least one point C belongs to open interval AB such that. So up to this, write the same sentence, and then such that. Then there exists at least one point C belongs to open interval AB such that the tangent at that point is parallel to the line joining these 2 points a f of a, that is capital A, f of a, capital B, b f of. So what we have? We have in Lagrange's mean value theorem f dash c. What is f dash c? Meaning of f dash c is what? The slope of the tangent at the point C. And f of b minus f of a divided by b minus a is what? Is the slope of the line passing through the line, these 2 points a f of a and b f of b. What is the slope of this line? The slope of the line, any line, is what? Is the difference between y coordinate, that is f of b minus f of a, divided by difference between x coordinate, that is b minus. So f of b minus f of a divided by b minus a means this RHS of this Lagrange's mean value theorem is the slope of the line joining the point a f of a, b f of b, and this is the slope of the tangent at the point C, and both the slopes are same, means the tangent at the point C is parallel to the line the tangent at the point C is parallel to the line joining these 2 points A f of A, B f of B. So what is the geometrical meaning? The tangent at that point is parallel to the line joining the 2 points A f of A, B f of B. Okay, so this line show this line passing through these 2 points, and the tangent at this point are parallel. So this is the geometrical meaning. Then the next theorem is what? There is no geometrical meaning of Cauchy's mean value theorem. Just write the geometrical meaning of Lagrange's mean value theorem. So write full statement that here write the geometrically Lagrange's mean value theorem says that if the function f is continuous on closed interval ab, number 2 differentiable on open interval ab, then there exists at least one point C belongs to open interval ab such that the tangent at that point is parallel to the line joining the points A f of A and B f of B. Okay, so this is the geometrical meaning of Lagrange's mean value theorem. So next theorem, fourth number theorem is interior extreme theorem. Interior extreme theorem. So the question is again set and prove interior extreme theorem. So we will see the this theorem and its proof in the next lecture.